And yes, we are live now, folks. So, hey, folks, this is Vishwas Nayan. I'm the host of this live LinkedIn podcast. It's not a weekly thing that I always do. It's basically friends in the community, the friends in the ecosystem coming back and giving me that sort of an introduction about a technology, oils and culture that is there. It can be an product manager or a project manager, or else it can be an open source enthusiast who's giving me a lot of intro about, man, this is a cutting edge technology that you need to be learning. And today I'm with my friends from Kyverno, Nirmata. Trust me, Kubernetes has its own set of complexities, and making it more structured in terms of getting the right policy, getting right approach in uh, getting the security aspect right first before you even start your Kubernetes journey. I think that was something a missing piece of puzzle, and I think Nirmata as an organization has really demystified that. There's an open source product. You can just go out and just check that out, and of course there is an amazing product in the enterprise space which is just going to not just give you that control over your Kubernetes, but policy and exceptions has been tremendously made simplified with Nirmata team. I think thank you so much, Nirmata folks, for being on the show. And I think special thanks to Rachna for setting all this up. It's a Sunday morning and she's in a function, but yet she's working hard to just get the show right. And hats off to her. Thank you so much to my friends from Nirmata. Thank you so much, Anusha and Malikarjun, for being on the show.
Hey,
Hey,
hi.
hi. Us for having us.
Yep, that's
Yep,
great.
that's great.
So let's start with the first question. There is a lot that goes behind, right? I'm using PSA, but why do I need Kubernetes to enforce PSS? I think Malikarjun can answer this question because he's working on that thing corely. And over to you, Malikarjun.
Like even with Kubernetes, when they deprecated PSS, they were like, I mean, this is getting too complex for us to manage. So even as the community to use it is was not very user friendly. That's why they ended up introducing PSA. But then PSA is then too broad. It's at the namespace level or the cluster level, so it's not very granular, which is exactly what PSS was, too granular. Uh, Not PSS but PSPs. So where they find that middle ground, they leave it to the community. So that's why they suggest that if you have a policy engine like OPA or Kyverno, you can use that for finer control. Uh, Maybe Anusha, if you want to
If
add
you want to
something.
add something. Yeah, I'll add some more context to it. So earlier, most of you all might be aware that we had something called PSPs, right? Pod security policies. And that got deprecated, and Kubernetes came up with this standard called pod security standard. So essentially, there are two profiles in it, baseline and privileged. So what PSA does is pod security admission. So it has an annotation. So if you set your PSA to be baseline or privileged, it is going to ensure all the controls mentioned under these profiles are enforced. There are about a total of 17 controls with baseline and privileged combined together. So with PSA, you can either completely enforce all of these controls or disable all of them. Like Arjun said, we do not have ability to fine tune or have a fine grained control on each of these. That's where Kyverno helps you with, you can either turn on or off individual controls, and not just that, you can say turn on individual control for the set of deployments or deployments with certain namespaces. So we'll now go through the basics of Kyverno. We'll just go through an overview so that all of us are on the same page. Arjun will walk us through that, and then we'll see how various kind of policies you can write with Kyverno. So not just for PSS, we have several other use cases that we have lined up for you today in terms of policy exceptions, cleanup policies, and some of the much newer features like how you can make external service calls, how you can sign your container images. We all know Notary became GA last week. So we'll also show you a quick demo on how you can sign your container images and also verify those images using Kyverno. All right. So with that, I think Arjun, you want to get started?
Yep.
Yep.
Vishwa, sorry.
Vishwas.
I think
Uh,
this is good, Arjun. You can start sharing your screen.
okay. Let me know if you guys can see it. Yeah,
All
can you see my
right.
screen now?
Yep, we can see your screen now.
Okay, so the title goes like Mastering Kubernetes Policy Management with Kyverno, and that's what we are going to do today. We'll talk about new Kyverno features and an overview of what Kyverno exactly does with the speakers. Anusha is a technical product manager. I'm a software engineer. We both work at Nirmata. And Nirmata is the company behind Kyverno. Um, so, what is Kyverno? We'll talk about that first. We'll talk about policy exceptions, one of the new features, cleanup policies, external service calls, then supply chain security with Kyverno, what's coming up next, and how to get involved in the community. If you're a developer, if you want to write docs, we need all hands on board. So, overall, Kyverno is a policy engine, and as the name suggests, it processes policies. And how does it exactly do that, and where does it work? So, it's a Kubernetes native policy engine, which means it runs inside the Kubernetes cluster. And you can see from this diagram, it may look very complex at first, but overall, it what it does is we have when a request is coming onto Kubernetes to admit a resource, then it has those admission webhooks, dynamic admission controllers, and these we can register. So Kyverno, its engine would be registered as a mutating admission webhook and a validating admission webhook. So whenever those requests come in, Kyverno can validate the resource that's being admitted and or mutated. Mutation means we are changing that resource and basically give it back to the Kubernetes API server to create that resource, keep it in etcd, and so forth to admit that resource. That is, and we have the Kubernetes, Kyverno components around here. We have reports controllers and different controllers, and each has their own function to generate reports, to do the background scans, to clean up the policies, clean up the resources that are based on the cleanup policies. So there are multiple functions to that, and we talked about its Kubernetes native, and this biggest selling point for Kyverno and why the community is so driven to move to it now is that it's very simple to use. You can write your policies in YAMLs. The language is very simple. The structure is very simple, um, and it's quite lightweight, even with all the work it is able to do. And when we look and when we say Kyverno policies are quite simple, you can see this in this diagram. So, as a policy can be defined as a set of rules, and each rule would have a match or exclude block. That is, we are filtering out the resources that we want to look at, and then we have these four type of rules: validate, mutate, generate, verify images. Validate rules. Check the resource against some given rule. For example, on the policy in the right, you can see that we have a pattern. So the validate rule would check the resource against this pattern. Mutate would, if the user, if let's say as a DevOps user, I want to do something, I want to insert a label or an annotation to a resource that's coming in, then I'd be using a mutate rule for that. And similarly, there's a generate rule as well. For example, when I create namespace, I would by default want to have some resources in it. Then I can use a generate rule to create resources based on the admission of one resource. And then finally, we have the verify images. We'll go through a specific use case of that. That is image signing. So verify images can be used to sign images, and then when we have signed images, we can verify its authentication. I'm sorry, for the authenticity. We'll talk about it in great detail when Anusha takes over. So, and also there's a policy library. So let me show you that. Uh, Kyverno has a huge policies library. You can see there are like 292 policies out there. This is the largest policy library for any policy engine, and it's pretty good. It's very detailed. You want to take a look at, let's say, HTO use cases. We have those. Or any as such, you can see it's categorized pretty well, and based on the resource, based on the use cases, it's organized and pretty neat. So if you want to get started with Kyverno, and if you want to jump into advanced um, uh, use cases, then that would be the place to go. So there's also, I should mention that there's a policy playground. So we introduced this recently. and you can try out Kyverno policies against different resources, and you can basically see how Kyverno works and how it would work for your resources. You don't have to run it in the cluster to test it out anymore. So now let's jump into the core details, right, of the talk. So one of the new features is policy exceptions. We already had policies. We talked about them. Right now, we can validate, we can mutate, and so forth. But there can be times when we, for certain use cases, when we want to have policies, but we also want to create exceptions. Now we can do that as part of this rule, exclude rule, but that is again, your policies can be, let's say, part of a CI pipeline. They can be deployed on a GitHub, in some repository, and they may not always be mutable, and they should not always be mutable following the GitOps principle. Then in those moments, what you'd want is you want to create a different object, which is called a policy exception, and you can use that to finally control which resources can be accepted from that policy. And so that way we are decoupling the policy at authoring from the exclusions, to say. And we will go through an example for this. And the idea is that we can decouple again, and that can lead to collaboration. As teams, we can review what can be accepted, what cannot be accepted, and the policies can remain in their own place, doing their own thing, right? And if, let's say, there's also the last point, you see, it's temporary exceptions. So we'll talk about cleaner policies, but basically policy exceptions are long lived. They would be there for as long as the resources, as long as the policies are, or as long as you have given a running, or you have deleted the policy exception. But there can be times when, let's say, within a certain period, we want to get rid of certain resources, or we want to create exceptions. Then in that case, we'll use cleanup policies. But let's look at first how the policy exceptions are. And it was some more detail about it. It was released in 1.9, and it is a namespace custom resource. So custom resources can be namespaced, or they can be cluster wide. Policy exceptions is a namespace custom resource. And it's so some more details, maybe it's better to show you with the example. And it does support background scanning. That means Kyverno would background scan to generate reports for us, so we know which policies are being violated in the cluster even before maybe you deployed Kyverno. From We can take a look at those resources as well. Kyverno can scan them for you, and that happens for policy exceptions as well. We have policy exception reports. Those also you can see, and that's part of the background scan. So now jumping on to the demo for policy exceptions. Before that, do we have any questions?
I think participants, please do make sure that you add your questions in the comment section of LinkedIn. I think Arjun, you have to just increase the font a little bit because
Is that better?
it's better now. So yes, perfect.
Okay.
Then what I can also do is I can also make it a full screen so that they can have a complete overview about the demo. And yes, of course, please do ask your questions in the comment section, folks. All right, Arjun, let's continue.
So I'm looking at the policy exceptions demo right now. So let's go through one of the policies. This is a disallow latest stack policy. So as the name suggests, it would not allow us to admit a policy uh, which has a image tag latest. So for example, and this is, you can see, this is set to enforce mode. That means there are two modes. There's enforce and there's audit. So in audit, I would just log that down, that yeah, this violation occurred. But in enforce, I would actually not allow the resource to go in. And we have two rules here. And as I showed you the structure, we have a match for pod and then a validation. So there are two rules. One is to make sure that we have an image tag, and the second is that it's not a latest one. Right? And as you can see from the policy, we have a use case, and it's very simple to write. So the structure is pretty neat, and the pattern is easy to specify. Even for very sophisticated policies, it can be very easy to write them. So I'm gonna deploy my policy first and do a run through. Okay, I think I delete. Let me delete that and redeploy. I have some other policies as well. So I'm gonna search for the latest one. Yeah. So that my policy is deployed now. It's set to enforce mode, and I'm gonna try and admit a resource. So I'm gonna admit Nginx, which is an image tag latest, and it would create a pod. So when I do that, Kyverno would give me an error. You see this, and the message that shows up is the same as this one. Right? Resource was blocked due to the following policies: validation using mutable image, latest, right? And now let's say that there is a use case that I have no choice but to do it. I have to admit a latest tag image, right? So in that case, I would want to create a policy exception, and this is what the policy exception would look like. Um, Specify the policy name, the rule names that we want to be accepted for, and the match. So match is the same as here. We have match for a pod here based on the resource kind. And as I mentioned earlier, this is a namespace resource. So I also have to specify which namespace this goes in. I'm deploying this policy exception inside the Kyverno namespace, but it can work on other namespaces which are specified here. So the pod I was admitting was in default namespace, and the next one I'm going to admit would also be in default. So when I create this policy exception, I can check if it's been deployed. So yeah, looks like it's been deployed. Now I'm gonna try and run the pod again. And this time it's admitted because we have that policy exception inside that namespace. But let's say if I were doing in some other namespace, let me create a namespace and I'm gonna deploy the pod to test2 namespace. In that case, it still shows an error. Yeah. Any questions on that? Okay. Okay, then I'll briefly talk about cleanup policies then. Cleanup policies were also added in 1.9, and they were the idea was that at times we may want to clean up or whatever we are leaving behind in a cluster, and we should not have to. Ideally, you would have to create different cron jobs and figure it out yourself, but it was a long-awaited feature, and we ended up adding it in 1.9. So the idea is that we can specify a schedule and we can match resources. Same again, the matching logic is same as other policies, and we can try and remove the pods that are pods like in this policy or any resource that we want to clean up on a periodic basis. And other than in contrast to the policy exceptions, these can be cluster scoped or namespace scoped. So that means and there are two. There are two CRDs for that: a cluster namespace policy, a cluster cleanup policy, and a cleanup policy. That's about it. I can go through a demo for that very quickly, maybe just a minute. So let's take a look at that. This is my cleanup policy, and what I'm doing here is I'm selecting the pods which have the can remove label set to true and cleaning them up in on a periodic 1 minute basis. Right? So let me quickly deploy a policy. And I have an Nginx pod running already, but I'm gonna create a new one which will have a can remove set to true. I'm gonna watch this resource. So it should be ideally cleaned up in 1 minute. Right. See, like this, I deployed the policy earlier, and it must have been a minute, and so now that pod is cleaned up. But Nginx, the pod we were running earlier, that did not have this label set, so that's not cleaned up. And that's about it. So it's that simple to use. It's super useful. And now let's quickly talk about external service calls. So with Kyverno, we were already supporting us talking to the policies. We can fetch the data from Kubernetes API server, but uh, we also allowed the external service calls support to the services that are running inside the cluster. So now I can do get and post HTTP calls to them, and based on that, I can create a context in the sense I can gather data from them, right? And it's all, they are also like pretty neat to use and pretty useful, because now you can write much more complex logic. You don't have to rely on static data as such, that comes from a config map or something to validate a policy against some data. Now this data can be dynamically retrieved from the policy, from the pods, or from the deployments, or from the services that are running inside the cluster. I'm gonna do this. It's a very simple use case. So I have, maybe I can just show you what I'm doing here. I have an echo server, so it would just echo out whatever HTTP request I'm sending to it, and I'm gonna send it a GET request, a very simple one, and I'm gonna validate, let's say, the email. So I'm gonna send an email request to it, as in this policy. As you see, I'm gonna send an email parameter, and I'm gonna validate whether that email is equal to test@nirmata.com. And if that is the case, I'm gonna not let the resource be admitted. So from the match block, you see I'm looking at a config map. I'm going to apply this rule to config maps that are being admitted. And for that, I'm going to do an API call. So this is the method is set here within the API call. And then I have a service. The service URL goes like this. So when I deploy the echo server, I'm going to create a service for it. And then Kyverno would send the request to this service with this parameter that I've set for the GET request, and then it would retrieve the appropriate parameter from the output, and we can then go on and validate that. So you see, if I set the context to email, so this email contains whatever data I'm getting from the service, and that is my key here, and that I'm just validating. If the email is set to test@nirmata.com, then deny it. That's what it means. So let's go on and create a policy for this policy first. I've deployed the policy. Now I'm going to create the echo server. I'm also going to create a service for that. Looks like the echo service up. The service is up. All right. Now I'm gonna try and admit two resources, and then those resources are very simple. They're two config maps. Um, One is a config pass, one is a config fail. So the config fail one, is expected to fail because the email field is set to test@nirmata.com. And basically what I'm doing is I'm just, with this echo server, I'm taking whatever data is coming from the config map, giving it to the echo server to echo it back. That's it. So the idea is to demonstrate that we can do service calls. So I'm taking this data. You can see request.object data.email, which means I'm taking this email field from here, from the config map that's being admitted, sending it to the echo server, and then echo server just echoes it back to us, and then we check it against the policy. So I have tested nirmata.com, so config fail should not be admitted, but config pass should be admitted because that has a different email. So when I try to admit this config map now, config path YAML, let's say. So you see the config map is created. if I try to admit config fail, then it's denied because in that one I have test@nirmata.com as the email. So that's and of course when we are doing external service calls, we also have to think about uh, the availability of the other dependent service. So in case let's say the service is too slow, then since it's an admission request, it is going to time out. So we have to engineer it well, and because now we are now the policy is dependent on an external source. So when this policy ideally when it times out, then the since the admission request itself has timed out, the policy did not get a chance to complete. So in that case, the resource is not admitted because we timed out the admission request itself. So that was it for the demo on these. Now I'm going to hand over to Anusha. She's going to talk about image signing first. And over to you, Anusha. Before that, if there are any questions, I can take them up quickly. Which was your mute, I guess.
Oh, dude, I'm like crazy stuffed in terms of the digital world. So yes, so one question is like the policy exception was in the Kyverno namespace and not simply in a default space. So why is that mechanism taken care by from the Kyverno side rather than just making any package that you put as an help package, it just goes and sits down in a default namespace. But why is there a new namespace created which is called as Kyverno?
Oh no. So like the Kyverno namespace was already there. I just decided to create it in a different namespace so I can show that it's a namespace resource as such. That's it. So there was no particular reason behind choosing the Kyverno namespace. It can be in your default namespace as well. No reason as such.
Perfect. Then I think it's time for us to invite Anusha on the podium and we can just go ahead with it.
So can
Okay.
you guys hear me?
Okay. Hey, Anusha.
Can you hear me? Yeah.
Yes.
Okay. Okay, I just want to add like one bit to that previous question. Like Arjun said, you can create it in any namespace. There's no restriction as such. But one meta is that you have to configure when you're deploying Kyverno itself. You have to configure in which namespace your policy exceptions will be created. This is because I can give you a real life example wherein whenever I interact with customers, um, sometimes the question is the security team is usually the one that enforces all of these policies. But then the development teams would want certain exceptions, as simple as change enforce to audit. So now, in as a best practice, you should not allow anybody to go and change a policy, right? So that just beats the purpose. That is where policy exceptions were created, so that you have a proper administrative way to get exceptions for certain policies and rules. Now that we know how powerful these exceptions are, their use has to be limited. So if you start creating exception for every policy that's there, then don't have policies at all, right? So that's why it is very important to just restrict that to a single namespace as per best practice. And that's because you have a unified view of where all your what all your exceptions are there, and what resources or policies they're accepting. But other than that, there is no reason that you cannot deploy it anywhere else, but it's as the terms of best practice, as security best practice. I think there's a question.
Yeah.
There's a question.
Can we have cleanup policy to delete services which don't have underlying pods? Arjun, how do you detect services without pods, that don't have pods?
So we
So
can
we can
we can look for the we can scan the pods and see if there are any match logic.
match logic. So basically, the idea is if match logic, because one example is you can clean up pods or you can delete pods that don't have a, say, a higher order controller. Like if you're just creating random pods without a deployment or anything, then you can definitely clean up. Oh yeah, endpoint. So okay, so if the endpoint is empty, then does it mean the service doesn't have pods? Then that definitely can be your match logic for all services that don't have an endpoint or endpoint is nil. You can go ahead and clean up those resources. Yes.
Sure.
Sure.
Over to you,
Over to
Anusha.
you, Anusha. Okay, thank you. Let me share screen. One second. Okay, cool. So we saw about sample. Okay, Ajay is asking sample example. We can definitely point you to the pods without a deployment example. I think it would be fairly simple. Arjun, would you mind sharing that example? Uh,
No, your voice.
no, your voice.
Sure, Arjun, you can start talking. I think Anusha, you're on mute.
Yeah, I'm sorry, I couldn't hear your voice was breaking.
Sure, you can share an example there.
Okay. Again, I'm going to share my screen. Yeah. So we're talking about policy. Sorry, what example were we talking about? The voice was breaking.
You can talk about an endpoint example. I think
So I
I'll
think
just
I'll
get
just
an.
get an.
Sample example for cleanup policies. No, can you see my screen?
Yes.
Okay. Yeah. So just like we were selecting the cleanup policy based on this one, based on the match labels, we can similarly have more complex projects. So there was actually a slide that I should have referred here. But so it's not just related to labels. You won't just look for labels. There you can do pattern matching and a lot more complex project to filter out those resources that we can match here. And you can read about it here on Kyverno.io. So earlier it used to be pretty simple. We had very simple selectors, but now we have enhanced those as well. So you can talk about selectors here. Let me show you, and I'll just drop the link for you. Um, Selecting resources. So this one you can check out. Is there a way I can send the link across, Vishwas? Or maybe I'll just put it in the private chat and you can send that
Yeah.
across.
You can just put it in the private chat.
Okay, yeah.
Sure. I
Cool.
think
Any
Anusha,
other
it's
questions?
time for you to. I think Arjun, it's a good way that you just pointed out to the documentation page so that they can go and explore Kyverno even
Even
more.
more.
I think Anusha, it's time for you to join the scheme.
To join the scheme. Yeah, I think today my internet is bad, headphones are bad, and uh, let's try. Yeah.
No problem.
No problem. Okay. Let me see. So I have to do present again. Okay, fine. Okay, all right. Yeah, I think okay. Ajay had one more comment. Pods without deployment is static, but service without pod is a bit dynamic. So for such things, you can run the policy in a background mode, so that and you can set the background interval so that every hour or every day or every week you can scan for such services without endpoints, and those can be cleaned up. All right. So moving on to image signing and verification. So this forms the base of our secure software supply chain security. Okay, there are different steps in this. So let's start with step one. So this is where an administrator sets up policies for different clusters, and this we call as the policy administration point. Now, these policies are specific to, it could be specific to your organization, because if you are a bank, something like RBI guidelines could be of primary importance to you, or if you are a retail store, maybe just basic pod security standards or few image security policies could be enough. So whatever the policies, the administrator set up policies, and we call this as the policy administration point. And second is a developer triggers a build. Here specifically, we are talking about image security. So we are taking this example where developers, whenever usually they write application code and they trigger a CI/CD build, the process is that the code gets built, a container image is built, and then finally this image is pushed to OCI registries. So image attestations are pushed to the OCI registry is the third step. So as part of your CI/CD, you can build an image, but along with that build step, a general best practice is to sign the container images, to create SBOM reports, to scan your image for vulnerabilities and generate a vulnerability report, and attach all of these signatures and manifests as metadata to your image, and store all of that in the OCI registry. So as we can see, the CI/CD pipeline has different attestations for a given image. It could be provenance data, it could be vulnerability scan, SBOM, and even signatures are stored in OCI registries. And finally, the fourth step, this is the policy enforcement point. So this is where admission controls like Kyverno comes into the picture. So what this does is, whenever you create a new deployment, it verifies whether the incoming pod or the incoming request, the incoming container image has valid signatures, valid attestations based on whatever you did in this previous step. So this acts as your enforcement point, wherein you can write any number of rules to check whatever rules that you want. And then finally, your deployment will either be allowed into the cluster or it will be blocked at this step itself. So again, just going through. So as an admin, we will, in this demo, I'll be doing a demo as well. So in this demo, we'll set up a policy. We'll look at what our policy looks like. We'll have an image that is already signed. So for signing the image itself, there are different options available. So we have, you all must be aware about the cosign project. This is from Sigstore. So you can use cosign to sign your container images. You can also use notation to sign your container images. This is a sub-project under the Notary project. And Notary went GA last week. So you can use either of these tools to sign your container image. But we'll see how we can write Kyverno policy to actually enforce that your container image has been signed. And if your container image is signed with the valid key, only then the pod will be allowed into the cluster. But if there's an unsigned image or an image that is signed with a separate key, then those pods or deployments would not be allowed into the cluster. So this is a simple four-step process. And talking a little bit more about, I can't get this to at once, 1 second. Okay, this is what I wanted to talk about. So yeah, now coming to the Kyverno part of it. So we have support for cosign. This was introduced in 1.9 itself. And then Notary, it was introduced, the support was introduced in 1.10. This is how a verify image policy looks like. So Arjun has previously shown what a cluster cleanup policy looks like, what a policy exception looks like. So all of the starting bits are the same in a Kyverno policy because everything is YAML, and we have a custom resource for policy itself. So this is a cluster policy, and the validation failure action here is enforce. That is, if the rules evaluate to false, it means incoming request will be blocked. And then we have the rule here called verify signature notary, because I'm using an image which is signed using notation. And match is on resource kind pod. Now verify images is of type Like I said, we support both cosign and notary. So here I'm using the type notary. Image reference, I'm giving all images that are in GHCR Anusha. All of the images in this registry should be signed with whatever certificate I'm going to give here. Now, attester count is 1. So here I'm saying it should have at least one signature with this certificate. So you can even increase the attester count. And here is the public certificate that I'll be providing. So not just these, now here we are verifying by cert, but you can also verify by public and private key in case of cosign. You can also have keyless signature and verification, and also using the X509 certificates. And this is just a hierarchical view of what verify images is. Verify images is what I have here on line 17. So we have different types, cosign notary, different references that you can specify, and then how many attesters you want and what are the attestations. So here I'm only verifying for image signatures, but you can have any kinds of attestations here, like in this diagram. Okay, I think my navigation is too slow. So earlier we saw that yeah, attestations could be provenance data, even it could be vulnerability scan reports, SBOM reports. So the attestation can be anything, but the way you verify all of that in Kyverno is under the verify images keyword. Now let's quickly look at how this works. Okay. So here I have a kind cluster. Wow, this is super slow for me today. And I have Kyverno deployment running. So as you can see, there are 4 different controllers for Kyverno. This is yet another enhancement in Kyverno 110, is that earlier we had only 2 controllers, I think admission and cleanup, I guess. Now the architecture has become more distributed. We have admission controller separate, background separate, cleanup controller separate, and even reports separate. So I have Kyverno up and running. Let me look at the policies. I don't have any policies yet, but let's look at the images. So notation, using notation CLI, you can also sign the container image. You can see how many signatures are associated with this particular image. So my image is GHCR Anusha Notary example, and I have 3 signatures associated with this image. Whereas I also have an unsigned image. So this is my unsigned image, which has no signature at all. And like I said, I use notation to sign my image, but all my local keys that I've generated will be in this location. So I have a cert and a private key. So I've signed the image using this key. Yeah, I think let's look at the policy itself. So this is the same policy that I was talking about. It's a check image notary on resource kind pod, image references for GHCR Anusha, and this is my public certificate. So let's apply the policy. Okay, super slow today. I'm really sorry about it. Yeah, let me try again. No. Okay. I think it's taking long to apply the policy itself. Okay, perfect. So now that I have my Kyverno policy ready, this is set in enforce mode and it is ready. So let's quickly try to create a pod. So image is the one that is that has signatures. So let's try to run this. And maybe the pod test is created. But now what if I try to run my unsigned image? Yeah. So we see that this pod this time was blocked because of this policy, check image notary. And it says no signature is associated. Make sure the artifact was signed successfully. So here we saw a case where an image with the correct signature was allowed, but an image that had no signatures associated was blocked. But if you can also try this as an example later on, is that use a different set of key and certificate and sign it separately. And even though you can try with the same certificate and see that probably you're going to get a different error message that the signatures are not matching. So that could be an exercise post this call. But I'd like to get back to this. Are there any questions so far? Do we require any additional license for Cosign or Notary? Not really, because those are open source as well. So in the end, I have linked to Notary and Cosign getting started pages. So do give it a try. It is super simple to just install the Cosign or Notation CLI and simply get started. Okay, now coming here. Yeah. So what's next for Kyverno? So we have something called the validating admission policy support. This many of you might have heard. Validating admission policies in Kubernetes was introduced as an alpha in 126, and I believe in the latest release it graduate. Did not graduate. I think it became beta. But the idea here is that validating admission policy is being proposed as a Kubernetes native resource. So it means policy engines like Kyverno or even Gatekeeper, which are essentially admission controls that are webhooks, the request had to leave the API server and get processed in these webhooks or in these admission controllers. But with validating admission policy, all of this processing of rules can happen within the API server itself. So that definitely is going to improve the performance. But what does it mean, right? We've had users ask us like, does it mean I have to switch now from Kyverno to validating admission policy, or do I not use validating admission policy? So that's not really true. It's not an either or question. So if the validating admission policy uses a language called common expression language to write all your rules, and is Kyverno is planned to integrate very well with validating admission policy. So in our upcoming release, which is 111, you will see that we will add the capability to even generate validating admission policy view and policy reports. All Kyverno output you can view as policy report. Similarly, we will add that capability for your validating admission policies as well. So whatever kind of policy you have, you'll be able to view reports in a unified way. And then there's much more integration that's incoming. So do watch out for our 111 release. And then we also have policy report scalability. So if you are a mature user of Kyverno, you must have run into this problem where policy reports start consuming majority of your HCD storage, which leads to all sorts of problems. So we in the policy working group, both Arjun and I are also part of it. So we have done some changes and enhances to the policy report API itself that can help you configure and which will put less burden on HCD. But in Kyverno also, we are planning on introducing an API aggregate layer wherein you can redirect all your policy reports maybe to a different storage. So that will further enhance the policy report scalability. So this is also something that is planned for 111 and 112. And then process arbitrary JSON and CLI. So this is also a pretty cool feature wherein till now we all know Kyverno as a Kubernetes native policy engine, right? So it means you need a Kubernetes resource to write a Kyverno policy and rule. But at the heart of it, Kyverno is just a rule processing engine. So as long as you have any JSON, you should be able to write same policy and rules for those JSON as well. So this idea we want to first introduce in the Kyverno CLI. If you're not aware of the Kyverno CLI, do give it a try, because it is super helpful in authoring policies, in testing different policies, how it reacts on different resources. So it is super useful. And we want to introduce this feature in the CLI so that for any piece of JSON, you should be able to write a Kyverno policy. And there are much more planned. These are some of the highlights that I'm looking forward to. But there is a complete list in the milestones that are listed. So please take a look. Are there any questions so far? No. Okay. So moving on to summary, we are already 50 minutes into this live stream. So we saw how Kyverno is becoming the de facto policy engine. So in this session, we did not cover much of the basics. We just gave an intro to what is Kyverno, and we directly jumped into policy exceptions, which are some of the advanced use cases. That is because Kyverno has been around for a while. It is widely popular. So we thought it might be more useful to actually talk about more advanced use cases rather than telling how to write a validate policy. Those are all the signs of Kyverno becoming the de facto policy engine. Everybody is using it, loving it. So we are now ready to talk about more advanced use cases, and then providing exceptions to policies and rules without compromising the policy integrity. So this goes back to the point that Arjun was showing, wherein policy exception is a separate custom resource in itself. Usually, before policy exception, if somebody wanted any sort of exception to their namespace or to their deployment, you had to go and edit the policy itself. So we have something called match and exclude block, right? So you had to go and edit the exclude block to exclude your namespace or to exclude your own deployment. So it means you are going and editing an already existing policy, and that is not a security best practice. Usually in an organization, only the security team or maybe the platform team has access to actually deploy and edit the policies, and not everybody else. So policy exceptions brings that administrative process to actually request for exceptions, and then without compromising the policy integrity. And then combined with cleanup policies, you can unlock new use cases. One we spoke in the chat today is like how you can clean up services without endpoints. But combining this with policy exception, what we normally tell users is that policy exceptions again should be used with caution. So it is very much important that policy exceptions are short-lived. You do not misuse policy exceptions. So generally, you can create a cleanup policy for a given policy exception, and you can say delete this particular policy exception after 1 week. So this makes policy exceptions time bound. It means whenever, say, a developer has requested for a policy exception, they can now the administrators can be assured that the policy exception is going to get cleaned up after a week. So there won't be any policy exceptions lying around in your cluster so that you have to worry about. Then we saw about securing software supply chain by image signing and verification. So most of the times, what I've heard seen some customers do is that they do sign container images, but that is only half part of the security story, right? So it's not enough if you just sign your container images, but you also to verify them at the time of deployment. Now you can use cosign or notation, but with Kyverno, you can verify either of these signatures. And then, integration with cosign and notary. So cosign was introduced in 1.9 and notation support was added in 1.10. We plan to enhance this further because notary has capability to even sign artifacts. So we will be adding that support in upcoming releases. And then quickly, how to get involved. So we all know Kyverno is open source. We are on Kubernetes Slack and CNCF Slack. You can join the channel Kyverno. We also have a weekly contributor meeting wherein you can pick up good first issues. It's all tagged on GitHub. So we look forward to your contribution. And if you're just getting started with Kyverno, we have a thriving community on Slack. So do shoot your questions. No questions are silly. So please feel free to ask any questions. I'm sure one of the team members will definitely answer your queries. And these are some of the references we use today. Yeah, so please go over it and let us know your feedback. And we at Nirmata also provide an enterprise version of Kyverno, and this is where you can go and try the enterprise version for free as well. Yeah, that's about it.
Thank you so much, Anusha. That was an amazing demo. Not just that, Kyverno is building a huge ecosystem in terms of security. I think I met so many guys who are in the security field, and they really told me, man, Kyverno is making a magic in terms of policy and other stuff. No, not just policy. I think you are putting and huge engineering efforts in terms of getting Kubernetes right, in terms of making it right, HIPAA compliance, SOC 2 compliance, whatnot. So there's a lot of things coming out in the market, and I think huge shout out to the folks from Nirmata for open sourcing the project first of all, and also trying making sure everybody gets an hands-on experience on how to build something on Kubernetes more securely. Thank you so much for that. I think Anusha and Kumar, if you both have anything to share as a final thought, please do go ahead with it. I think Arjun, you
I
can
think Arjun,
share.
you can share. Yeah. So like we all of course work very hard on our enterprise products, but we want to see Kyverno thrive as much as possible. And I would definitely suggest you guys to check it out. Go to kyverno.io. There's a lot of resources if you want to try Kyverno. Try out the playground. Um, and if you want to contribute to as a developer, there are good first issues you can look at. We also take LFX mentees quite frequently. We have three this time. And if you're a student, that's a good way to start with cloud native to join Kyverno or contribute. So do check it out. Do check out our GitHub. Follow us on Twitter and keep engaged with the community.
Sure, Anusha. I think you can share your thoughts as well.
Yeah, I think the LFX point was really good. So we don't really have Hello World kind of projects listed because some of the features that we spoke about were, kickstarted by our LFX mentees. So there's a lot to learn and, and good features to contribute that will be used by both our open source users and enterprise users. Yeah, we act, and to your point, which was like, we also seen tremendous increase in Kyverno users, like from every KubeCon to KubeCon, like the initial one that I attended as a Nirmata employee. So I had people come and ask, hey, what is Kyverno? What is this new project? To the next KubeCon, wherein people come and say, hey, I love your project, or I've been using Gatekeeper for a while now. I want to migrate to Kyverno. Can you help me with it? And for that reason, we have a complete migration guide from Gatekeeper to Kyverno. So if you are looking to move to Kyverno, don't think of you've already invested in something else. Don't think of it as a sunk cost, but we are here to help you out. And just reach out in Slack. So we are always active over there. Yeah, we hope to see some of you all pretty soon.
Sure, that's great. Thank you so much, my friends. It's a lovely session. Sunday morning we are just out there, and you folks are asking so many questions, and we are ready to answer that because we are so jacked up about the things that happened today. Because mic's not working. Of course, there are a lot of things which went wrong, but yet you stayed with us and you just made sure that we deliver the demos and you asked some amazing questions. It was an amazing day. I think thank you so much, my friends. This is the end of the broadcast. This is Vishwas signing off with my friends Anusha and Kumar. Thank you so much, my friends. Meet you with a new guest, a new topic, probably on something related to Kubernetes security. I'll come back with another guest, another LinkedIn stream. That's it, my friends. Thank you so much. Signing off.
Thanks, Vishwas.
All right.